Good afternoon. Thank you for attending our session this afternoon. My name is Steve Whittam. I represent Whittam Associates. Many of our end users over the last several months, staying at home, trying to develop new technology to assist their companies, have requested from us a presentation on how we might go about creating Diewall construction in the wood industry. And Diewalls don't necessarily have to be developed out of wood. It could be metal, plastic, glass. It could be a combination of many, many different things. Also, Diewalls do not have to be straight lined. They could have curves in it. They could have arcs in it. In fact, they could have twists in them if it was designing in that fashion. They might have structural steel in them. So depending upon cantilevers and what have you will determine, of course, the method in which we might utilize the system. Now, in today's session, I can't really cover all aspects of the usage of Inventor for every one of those particular items, but again, if any of those seem to be issues or problems or concerns or design concepts that you're thinking of, please get back in touch with us. Diewalls are used in boats, planes, RV buses, all types of construction, trains. So the usage of a tool of this nature or construction of this nature can be quite important. You'll also notice that in some of the videos I'm showing you that you'll also see that it could have varying heights, where a Diewall starts at one elevation and then goes to a second elevation, which would mean there would be, double bevels on the top of the ribs and a handrail of sorts that twists. Some of the things also are very basic, like reception areas that almost every, office, hotel, hospital, or cash wraps, they all are using some form of this. So today's goal, of course, is to try to templatize as much of that as possible so that we can save 50, 60, 70% of your time the way that you're doing it today. As an example, the way we initiate this templated environment is we create a curved Diewall plate that has all the information already associated with it. Radiuses, lengths, number of dados, depth of dados, width of plate, amount of curve, all the necessary key components that one needs to build a plate and also adjust the plate later on. So let's get started with actually building that template. The first step is to actually draw some diameter or radius, and I'm going to say the outside radius, outside diameter, whichever way I think I would like to actually start constructing and building. There's no absolute here. So I gave it a name and I said the outside radius equals 96 inches. I'm also now offsetting from the outside to the inside and saying that the plate width is going to be 4 inches or 5 inches, and these are nominal measures. Next step is let's draw lines from the datum point all the way horizontally to the outside quadrant, and from the datum point off on some angle. I don't care what the angle is. And let's trim up everything that isn't necessary at this moment, including the horizontal lines. Okay, so we've done that. The next step is let's go ahead and add a couple of constraints, horizontal, and let's make sure the bottom of this radius is horizontal to the datum point. And now let's draw a line from the datum point to the edge of the outside of the radius. I'll also now make sure that they're tangent or parallel to each other and make it a construction line. And the last step is to add a diameter to the overall radius, the full radius of this, okay? And this is the curve radius, or the curve angle. And I set it to 135, 145 degrees. And if you take a look at the bottom right corner, it's fully constrained. So I know I'm pretty good. I'll now go into iLogic and I'll create a form. And the form will have all that information in it. So you could see outside radius, I'm bringing over plate width and curve angle, or whatever you named it. And we pick OK. And then we'll open up the form again and we'll test it. Again, testing it is critical. You want to make sure that testing it here, it's going to react the way that you're expecting it to react. So it's doing everything that it needs to do. It's maintaining it. There's no error conditions whatsoever here. And it allows us to take the next step together. If there's a problem, it has to be fixed now before you get too deep into it. Okay, from that point, what I'm going to do is take a look at it, create a top view or side view, change it, change the view cube if you want to, and I want to extrude this to the thickness of the plate. So if I now pick extrude and I give it a value, let's say thickness equals, or plate thickness equals 3/4 of an inch, 1 inch. It really doesn't make a difference right now. It could be whatever you would like to call it. Okay, so now we have that done. Now, if we wanted to go further with this, we have the ability to now add the actual dados that are on either side of this plate. Now, if you take a look at what I'm doing here, is I'm not really being that careful. I drew a line, and now I'm making it parallel to the bottom, and I'm making it parallel to the angle. That's most important. And I'm going to trim off the balance. Again, this will maintain constraints, and I know they'll be accurate. And now I'll add some dimensions to it. Dimension could be dado width equals 3/4 of an inch, dado depth equals 1/4 of an inch, and as I said before, the naming conventions are, of course, your own, whatever you would like it to be. Really won't make a difference. I just like to be consistent. Then we'll extrude it, and extrude it to dado depth. These common naming conventions should be throughout the engineering department so everybody uses it similarly. My suggestion, it just makes it easier for you to work on other people's job. You can publish these, make them available to everybody so that it's fairly straightforward in when they have to deal and work on certain things. Okay, interesting. Now what we're going to do is create a pattern. But we're going to create a rectangular pattern, not a circular pattern. So if we touch the first dado, tell it we're going to pattern a feature and pick the direction, which is the lower radius, because that doesn't have the dados in it. And I'm going to give it a variable called dado count. Now I don't know what the spacing is, but what I pick instead of spacing, I pick curve length. And because I picked the bottom edge, that defines what that curve length was. And you could see now that I've got 6 of them because I said dado count equals 6. But if I do more, I can say adjust and pick direction, and they'll all adjust for me accurately. And this is a rectangular pattern, so that's now done. Again, very simple, it's straightforward. Go back into the form, and now we add all those particular values I didn't have previously, like thickness, like dado width, dado depth, and dado count. If we want to, if we spell something wrong, we can change its name here fairly easily. We also can start making the dialog box look a little bit better by putting splitters in, or creating groups, or whatever you need to do. This is not absolutely necessary when we start out because we're testing. So now our menu system is growing even further, and we really don't need to know too much about iLogic to accomplish this task. Nice thing is dado count, you can see you type in a value and immediately it gives you the value you're looking for, which is really, I find kind of impressive. You can change the depth, you can change the width. You have lots and lots of possibilities here right now. And something like this can be done within a couple of minutes. And then this, of course, will be saved as a template. And then when it gets called up, it's a brand new plate for every new job. So it's not using the same library part over and over and over again. As we start controlling it even more so, you'll start seeing that the curve angle, which is 145 degrees, now 175 degrees, or the plate thickness. So you build into your template all the necessary possible considerations that you would have building your job. And that's what we see as a real benefit in constructing this. Now, it doesn't all have to be in one template. It could be in multiple templates. And I just wanted to show you that, what I'm going to do is now create some pie lines to show you the accuracy of what we just did. So this is just a quick example. Nothing really dramatic here. I'm creating line work from each of the individual corners of the dados, at least 3 of them. I'm not going to do every one, but this is just testing and showing you that that this is accurate. If I now say they're parallel, and of course I use a lot of constraints, I find it's the easiest way to build. And I then grab the endpoints and pull. You'll see that they'll go right through the center of the datum point. So again, I know that those are absolutely accurate. So we don't have to think about this. So again, we've now just laid out a plate that's equal segments, and it's fully controllable. Start points work quite well in this particular fashion. Now, next step, ribs. Let's say I want to create a simple rib. Now, of course, ribs can be incredibly complicated. In this particular example, I just wanted to show you that I can use the existing dados. I can tell it the rib height is going to be a value. The rib height, of course, then has the ability to change with the menu and adjust. Either they're going to be static, or of course they're going to be variable. Like this, I'm trying to make everything variable here if I can. The other thing is make sure it's a new solid. Do not join them together, because obviously we're going to machine these. This could be nested. This could be individual parts. And you're seeing certain things like I'm creating a work plane on the bottom, and that work plane is going to actually control the kick. You know, how high the kick is going to be off the floor. Every rib is different, I know that. But you can expand on this on your own and use this as a base to at least start considering different options that you have. I'll start on the top in this one and just create maybe a 4-inch overhang. Again, lots of different ways. The actual ribs themselves could have concave or they could be flat. It's up to you, of course. Again, a lot of times, if you notice, I am crossing over things and trimming. That way I don't miss anything and I don't have to zoom in too far. And I'm really getting easy accuracy. It's not really taking up too much of my time to accomplish it. But again, this is just a technique. There's no absolute in Inventor in the way that you approach it. And we'll just extrude that, and I'll say extrude it down to the work plane. And this is not a join, okay? This is not joining. Why? I don't want two separate pieces. I mean, it's not a new solid, I'm sorry. It's not a new solid, it's a join. Join is one single piece. And let's say it does have a cutout in it. Many ribs have some form of a cutout in it. I'll make an oval cutout. I'll also center it in the cutout and also set it up so that it's a certain distance off the top. Let's say 6 inches off the top and 6 inches off the bottom where the kick ends. That means no matter how deep how high the kick is, the slot is always going to be 6 off the top and bottom. Okay, we'll take a look at it in an ISO view, and we can turn off the work plane if we want to. We don't necessarily have to, but again, we can also bring in the information, because every time I add a parameter, those parameters can be added to the system, as you see here. And again, I just like, organizing it a little bit more so it's easier to find as I go. Later on, I'm going to clean this up even further. Might put a picture of the image on it, just making sure that everybody understands if I'm in a work group, what it's asking. And then by testing it, as you see here, the thing works just fine. I like testing just because I don't want to get too deep into the model before I run into a problem and then I have to back out. So our next steps, maybe we're going to pattern this, okay, which is what we've done previously. So if I want to pattern, this time pattern a solid, and it'll create new solids or new bodies, new solid bodies. It's pretty much the same thing as what we've done already. We pick direction. You can see this little arrow that forms that tells you the direction, and of course you can change it. And now I'm going to not use a quantity. I'm going to say I'm going to use dado count, okay? So when the dados change, the number of ribs change, and still it's going to be the curve length. And if I go to the more command, that's the little arrow at the bottom right, I could say I want it to go to direction 1 and pick OK. And now those are taken care of. There is still one problem, which we will correct later on, and that's the last rib is 3/4 of an inch off of the face. And that's going to be an easy correction as we go into the assembly. So just want you to be aware. So what might I do now? Well, obviously, I'm going to mirror the bottom plate to go to the top plate. So you create a work plane in the center, mirror it about. It's going to be a new part, a new solid body, new part. And we pick OK. Now we'll find also that the top plate, which is independent of the bottom plate now, really has to be 4 inches wider. So we'll just thicken it. And we'll thicken it by 4 inches. And that's now done. And we can turn off the work plane, of course. So it's a good idea to save your work. You know, you get too deep into it, something happens, and you might have some sort of a problem. So you pick save, of course, and you make sure you save it. You can name the solid bodies, bottom, top, left rib, right rib. You can create one rib and then pattern it when it's an assembly to get a correct material count. But I'm now creating the parts, and I'm making sure the parts go into the same directory that the actual original Diewall solid body template was. Okay, well, let's take a look at it. We're going to rotate it up. We're going to set the view cube the way we want. And we're in really good shape. If we want to change something now, oh, yeah, we got that last piece. So I'll take the grounding off. And ground the bottom. So, and this isn't necessary, but I'd have to write a formula to accomplish this goal. And in today's session, I wanted to make sure that novice users as well as intermediate and advanced users can get work out immediately. Okay, that's good. And of course we can save it. Now these are all individual parts. If you're using Woodworking for Inventor, now is the time, of course, to add materials. Materials, of course, maybe this is plywood, maybe this is some sort of Scandinavian birch, maybe it's whatever it is, you would add it. And by adding the material, not only will you now have a cut list, but you'll also have a bill of material. And of course, you can now go out and nest this or create individual parts. Also, it looks nicer. Again, you don't need our Woodworking for Inventor to do everything up to this point. But if you did, then you can see there's a little more benefit from it. Okay. Now, last step, okay, I want to create an outside skin. So the easiest way to do that is to use what's already here. So I actually created a new part on the top surface of this Diewall, and I'm touching the edge, projecting the edge, offsetting the edge. Let's say 1/2 inch. Let's say it's for a 1/2 inch material. And like a hatch pattern, I have to close the perimeters, okay? It has to be a closed loop. If it's not a closed loop, I'm not going to be able to extrude it. So again, quite simply, we're using the geometry that's there, and by using that, everything also will become parametric. And I'll say I want to extrude it down to, and I can pick, well, I turned the work plane off, but if the work plane was there, I could have done that. But what I'm going to do is pick the very bottom of the kick. Or I should say the top of the kick. and we pick OK. And we'll do the same thing for the bottom. Now this can be done on angles. We have tools to miter them, to trim them, to dado them. Again, depending upon your particular needs in terms of what you're building, this technique can be enhanced dramatically. So doing the same thing, I'm creating a brand new part. I'm touching the bottom plate. I'm touching the edge of the bottom plate, projecting it, and then doing an offset of 1/2 inch also. And then closing the loop by the two ends. Everything that you're seeing here is real time. If I wasn't talking, this is maybe about 10 minutes worth of work. And I can create multiple S's, curves. You saw some of the couches that were done this way, seating booths that were done this way. Diewall, straight line work that was done this way. And again, once this is done, this could be saved as a library item, this entire piece, and reused. Save our work, and then of course we can add more material to it, different material if we wanted. Again, that's completely up to us in regard to what we want it to look like. The grain direction. If there's relief cuts in it, if there's details in it, if there's overlaps in it, this is all possible too. Again, good idea, save your work. And you're now looking at a finished Diewall. Yes, I can do the inside also. Maybe it's not necessary, but now I can start fitting cabinets to the interior, put a finished end on a piece, extend it, whatever might be necessary. And also, if you take a look here, I'm changing the curve angle. And I changed the entire curve angle, and not only the ribs changed, but the outside facing changed. So I don't have to do it a second time. There's no errors, no cross-part relationship problems. There's no red cross at the top of the screen. And what I just did now is I opened up the skin. And you know that, how long is that skin? How can I cut this? What if there's cutouts in it? Well, what we can do is unfold the skin. So what I just did here now is I actually took the outside skin and unfolded it. And if we take a look at the extent, it tells us it's 240 inches long. So I know I have to put a seam there. I don't think I have a 240-inch piece of material. It's doing engineering for you also. So those are kinds of things that are happening, that you can take curved pieces and unfold them flat for machining and for documentation. So the hope is that you can create simple Diewall, straight Diewall. There are methods that say that if you had a Diewall that was a certain size, how many ribs it should automatically have. There's vast possibilities. So I do thank you all for being here today. If any of you need or would like this sample that I just created, please email me, and I'll be happy to send that back out to you. It is 2021, but I do believe I have a 2020 also. Again, my name is Steve Whittam. I represent Whittam Associates, and you can see our email and our phone number online if you need assistance. Thank you once again.